everything you need for making complete sci-fi colony and outpost environments. With the help of various blueprints and procedural systems, you can automate, optimize, and speed up the whole level creation process. A library of different sci-fi styled assets and natural meshes helps to create an interesting-looking rocky planet environment. Complete building blueprint system with interior generation and over 160 variables to change for walls, roofs, windows, furniture, stairs, colors, etc. Spline blueprints with various systems that help to create airlocks. Scattering systems for fast prop, item, and debris placement. Interactable doors, lights, items, machines, and furniture. High-quality sublayer-based material system fully supports and utilizes nanite and offers very optimal rendering performance. Easy to change colors and values like damage and dirt for every actor. On top of that, separate mesh decals add final high-quality details. Material layers are turned into material functions for easier editing, and assets are using material instances. Example level contains an environment controller to drive dynamic time of day and weather effects like rain. Advanced landscape material is also included with different layers using high-quality textures, distance and slope-based details, and virtual texturing support. Rocks can be automatically placed with PCG tools and with the landscape grass system. This colony pack can be easily used with other KK-designed sci-fi environments. This product is distributed as an asset pack. This makes it very easy to implement and import into Unreal Engine projects. Unfortunately, it can't transfer information like project settings. If you create a new Unreal Engine 5.3 Plus project, most of these settings will already be enabled. But to avoid issues and use all of the features that this pack can offer, you should enable the following settings and plugins. Procedural Content Generation, PCG system, allows scattering meshes in many different ways. To enable this system, you need to go to Edit and find a plugins. Then you need to enable the Procedural Content Generation framework, and after that, restart the editor. Then we need to enable some rendering settings. You should already have these enabled, but let's double-check. Lumen can be enabled from the project settings under the rendering and then dynamic global illumination and reflections categories. For nanite, you should go to platforms, then Windows and target RHIs. And make sure to use DirectX 12. You also need to enable SM6 there. I also recommend to use virtual texturing. You can enable that in the rendering settings by enabling the Enable Virtual Texture support. That's it, your project should be good to go. This pack comes with an example level called Example Level Colony 01. This level is using the world partition system, so remember to load cells first in order to see the content. Unreal will handle this automatically during runtime. I would recommend to play around in this level so you can get a better idea how everything works. You can also press play and explore it more with the example player that comes with this pack too. When you are ready, let's continue with the various blueprint systems next. There are two different building systems in this pack. One is a circular system and another one that is a more complex one that is used to construct buildings that are more box-shaped. These systems will construct buildings using different building library sets. This way, you can control building size, colors, damage, windows, roofs, doors, etc. Blueprint will then use hierarchical instanced static mesh components to construct the actual building. Some common variables are public, so you can tweak them in the level and create more variations between buildings. Others are private that you need to change inside that child blueprint. Most of the time, you don't need to do that unless you are creating new ones or want to make changes to each building instance. System is divided into different parts. First stage is the planning stage. In this part, the system will calculate building dimensions and generate bounds that are later used for the actual building. You can find a variable called Use Planning Mode under Control. Turning that on will make it faster to work and edit buildings, but you want to change that to false when you are done. This will then run the actual logic that generates HISMs and assign materials. In the same place, you find variables called floor amount, wide, and long. These are used to control the building dimensions and are the most important variables in this system. Everything else is then created based on these. Seed number is a handy way to generate different variations and keep those changes using a pseudo-random logic. It will affect every random function that the system uses. When bounds are calculated, the next stage is wall building. This is done for left, right, front, and back sides, and you can find individual control for every side under Control. You can choose to disable constructing specific sides totally, enable char disable windows, and so on. These settings are the most used ones and can have a huge impact on how the building looks. During the wall building process, the system can also add doorways and doors based on the door array. This is basically a list of rules where the system will replace wall pieces with doorways. You have an option to specify different door blueprints or leave it to none. Every building face will contain their own door arrays so you can have the most optimal amount of control. Building system will generate a roof on top of the last floor wall meshes. There are lots of controls on what type of roof meshes it will use, offset for those meshes, roof deco meshes, and so on. All of these parameters are stored under Control Roof. You can disable roof construction totally or choose to scatter roof decorations that are specified under Meshes. If you want, you can also construct sidewalks. This will construct sidewalks using the building dimensions. Then you can specify multipliers that will shrink or grow that system based on needs. Sidewalk system is useful to add structure under the building, and with sidewalk pillars, it's possible to make buildings appear to be poled on the ground. Sidewalk structure will be using its own set of meshes, and it's possible to change the appearance. System can generate multiple floors, dynamic stairs, pillars, and even some basic furniture placement. In order to use it, you need to open the Control tab and then enable the Construct Floor Boolean. This will tell the system to run the floor function. Then you can enable or disable the option Allow Multiple Floors that will construct floors based on the floor amount number. Under Floor Settings, you can also control Stairs settings. You can enable or disable stairs generation and control the stairs offset. Random Stairs Location will randomly choose where stairs will be placed for each floor, but you can disable it and manually specify this location using the Stairs Location X and Y settings. System will spawn a child stairs actor with correct values to match the floor height value, and you can change this actor to something else if you so choose. System also contains a basic furniture spawning logic. This system is divided into floor and roof systems that each have their own settings. Spawn furniture is the main switch to enable or disable the main furniture spawning logic. Random furniture deletion will randomly skip spawning furniture to achieve a more natural look. Then you can specify actor arrays for different cases like window, wall, corner, middle actors, and roof. This feature is used to add lights on floors and roofs. Circular buildings are using a simpler system that will help to generate building floor, walls, and a roof. Most of the control is happening by changing variables under the Control category. You can also change building appearance in a similar way, like in regular building actors, and variables for these can be found under Appearance category. Another benefit that you're getting with this pack are various environment tools. Let's discuss the Spline system first. This system is using a spline curve to spawn different types of meshes. This system can be divided into different parts, and it's possible to use all of them at the same time to have a very advanced system. Basic use for this blueprint is to spawn spline meshes along the spline. This way, meshes will deform and follow the spline curve accurately. Using instanced meshes is a more optimized way, because then we can batch meshes better. Unfortunately, SysEms are not supporting mesh bending in the same way that spline meshes do. However, there are lots of cases where we don't really need to bend meshes, so HISMs are a more optimal choice then. You can also spawn actors along the spline. These settings are almost identical with instanced meshes settings. There is an array where to specify what actors to spawn. An actor spacing value will control the density of how often these actors are spawned based on the spline length. Then there are options to spawn debris, pillars, and socket meshes. You can read more about what different variables do by visiting the pack documentation. Thanks for following this far. And if you're ready, we can continue with the rest of the environment tools. Stair system is constructing stairs using a basic logic that will allow the use of different stair mesh libraries. System will automatically handle mesh instancing, so stairs will be as optimized as possible in terms of rendering. You can also change the stair appearance and decide if you want to add actors on mesh sockets. Scattering blueprint is basically using two different systems to find transforms where to add meshes or actors. These systems are line trace based and plane based. Line trace based is more accurate but will be a bit slower to update when changing values in the editor. Plane based will just take random points from a plane and will ignore the actual environment. This is faster and works well when you need to scatter something on a flat surface. Building system already includes an automated pillar system, but this pack also includes separate actors to manually add pillars. This can actually do more than that, so you can think of it like creating linear structures that will have start, middle, and end. Like with everything else in this pack, this system will also handle mesh instancing and support similar appearance control to change colors, damage, and dirt. 95% of the assets in this pack are using the same parent material workflow. This have multiple benefits that range from material authoring to runtime performance and memory consumption. Important data is baked into vertex colors that will drive a generic submaterial library consist of tiling details. This allows us to have a uniform, consistent way of controlling materials for each actor using custom primitive data. Mesh decals are then applied on top for final details. Every interactable actor in this pack will be inherited from the parent class called BPP level object. This actor contains functions to handle automatic mesh instancing, door interactions, pseudo-randomness, and so on. That way, any actor inherited from this class can use these generic functions and makes it easier to have a more unified way of creating things like doors, furniture, lights, etc. There are 3 different Boolean variables that play a key role in this system. Is power on will tell whether or not the actor is getting power to operate. You can think of this like a light bulb that will emit light when it's part of a closed electric circuit. These actors will use this to toggle lights and some emissive parts. Next Boolean variable is active. You can think of this like a switch, so a fan will spin when it has power and is active. Last Boolean variable is interactable. This controls whether the player can set the active state or not. Is active, meaning the player is able to press a switch and make fan spin, for example. With these 3 variables, it's possible to have different functionality in different actors. For example, you can easily decide what displays and lights are on, and players are allowed to turn those off. This pack contains door blueprints. All of them are inherited from the BPP door actor that is inherited from the main BPP level object. Doors will use a sub-door logic. The actual door data is stored in a door dataset array. In this array, each array item will store data for each door mesh. There you can specify things like door opening and closing sounds. Furniture consists of various actors like lockers, desks, even toilets. These actors can also contain sub-doors that players can open. Furniture actors consist of different meshes, lights, and sub-doors. Because these actors are sharing the same parent class with Dr. Actors, it means that the same system applies here too. Some of these actors, like hydroponics for example, will use features like socked-based mesh placements to randomly place vegetation that will vary on scale. This pack comes with a library of different pre-made furniture actors, but you can always create your own and utilize this system. If you decide to do that, then remember to add components like meshes and lights under correct components inside the blueprint. That way, various functions will find correct components that it can use. Light actors are also inherited from the same base class, so it allows an option to enable player interaction. When Eyes Interactable is set to true, it allows the player to turn that light on or off depending on the state that light currently is. You can change appearance for the base mesh, but you can also change the actual light color easily by changing the light color variable. The Eyes Power On variable will turn the light off or on. Machines are behaving like any other actor that is inherited from the parent-level object class, but are meant to be used for actors that are outside. Solar panels, scanners, mineral pumps are some example of these machine actors. Sometimes the player needs to be able to pick objects and move them. For these kinds of actors, you can use the Pickable class. It contains few generic and useful functions. You can let it randomly choose from a set of different static meshes, let it randomly choose colors for them, and so on. This is just an overview, but remember that you can always read more about this in detail by checking the pack's specific documentation. This pack contains few procedural content generation systems to help with mesh scattering. In a nutshell, the system is basically finding locations to spawn different assets. These assets can be meshes, actors, or even pack-level actors. Most of the time, it does this by using point clouds that will be traced against the level geometry. Best way to understand how these pack-specific systems works is to open and study the example level. Let's change the subject a bit and cover the environment controller next that comes with this pack. It supports a fully dynamic day and night cycle and an option to control wetness values. You can specify hours, minutes, and seconds, and the system will update values based on that. Main logic is using curves that you can tweak for your needs, and the system also works in the editor. Feel free to explore and test what different variables do, and for more details, visit the pack documentation. Because this pack is using features like Lumen, Nanite, and virtual shadow maps, it requires a certain amount of performance to run. If you are running a modern desktop PC, then you should be fine, but there are always steps you can take to optimize it more, if that's needed. Easiest is to change engine scalability settings. This can help with Lumen cost, that is the most expensive rendering feature in this pack. Enabling virtual texturing and using runtime virtual texturing can help to optimize landscape material. Speaking of materials, remember that you can always turn various material parameters off to save some instructions. Last but not least is profiling, because optimizing really depends on the project and its needs. To keep this short, I would advise to check the optimization section in the documentation for more links how each of these topics works. Last topic I want to share about this Sci-Fi pack is the example player. It is based on the basic Unreal Engine third-person pawn with some changes like an option to switch between first and third-person views. It also contains interfaces to interact with level objects and items. That way, you can use that as a reference and implement similar functionality into your own player pawn. Example player is set to work in the example level. Inputs are also set up. That's all for this pack overview and briefly going through various systems that this product contains. Thanks for sticking along, and like I've mentioned before, I would advise to read the documentation for extra details. I also want to say a huge thank you for all the support you have given us so far. We appreciate that here at KK Design, and it really helps us push forward and create more meaningful content for developers to use. And like always, let's turn polygons into pixels and ideas to art.